I would like to introduce our speakers today. Dr. Naveed Sharwani, who's the chairman and of PrimisAI, and Dr. Sharwani is a seasoned executive and seasoned veteran of the chip design industry. 35 years of either design expertise, management, as well as entrepreneurial experience. And he's one of the people that are able to raise significant amount of money for investment for semiconductor companies, over 15 rounds from different VC companies. And he is a leader in the field and recognized in multiple on multiple directions. And he's the chairman of PrimisAI. And then our second speaker is Hans Baumeister. He is a pioneer in the AI area, and he worked in multinational companies and startups around just with a focus on operational improvements and excellence, and as well as the solid expertise in in ASIC design, RISC processors, as well as semiconductor IPs. For machine learning and AI, he's been driving innovation in the market as a founder of Neurono, the company, and which had demonstrated his ability to drive and change in the market, specifically around the AI. So I'm going to hand over to Dr. Naveed.
All right, Mohammed, thank you very much. First of all, I'd like to thank Mohammed and Andrea and the team to put together this webinar. And in particular, Mohammed's work in Efabless, along with Mike and others, for really popularizing chip design amongst students and researchers. It's pioneering work. And the work that I'm a very big supporter of from day one, when he started somewhere in 2008, and I met him for the first time. I believe that was in Open Silicon. He walked in and he said he has an idea to democratize chip design and tape out. It has been a long journey, but he has done wonderful. Very proud of him. So I think the comments I would like to make is that when I started in chip design was in early 80s. At that time, automation of chip design did not exist. Most of the chip design was done by hand. And when we started doing, many of the people who used to design was basically mask designers. And they used to tell us that chip design can never be automated. And this is what I heard repeatedly in early 80s. Of course, there was an explosion of chip design tools from mid 80s to by 1995. Huge number of companies came into. This is the time when Cadence and Synopsys and Mentor Graphics grew up into companies, Magma and many Dolphin and many other companies started. And I think explosion happened. But if you look at the history from that point onward, from 1995 to today, it has been a maturation of the design tools, optimization of the flow. But in that sense, nothing major has happened in the sense dramatic in terms of algorithms and things like that. So I think about 2 years ago, when we started looking at generative AI and what it can do for a chip design, that's when I felt that maybe in the last 20 years, something different is happening now. And I truly believe what is happening. So the journey of generative AI use actually started in a company called Rapid Silicon. It's an FPGA company. And our goal there was to build something that our customers don't have, makes it easier for them to program FPGAs. So we used to call that effort low code, no code approach towards designing FPGAs. As soon as the LLMs came up and ChatGPT came up, we realized that this low code, no code can actually become really no code, and we can start moving and start designing something that can help people who design FPGAs much easier, almost all automating it. And that's when this tool called RapidGPT was invented in Rapid Silicon. Very soon, they started growing and became more and more capable. Eventually, it was decided that we should spin this off from Rapid Silicon, and it became a new company called PrimisAI. So in the journey in the last year and a half, what I have noticed, I believe generative AI is going to be the next major change in the whole chip design industry. Why is that the case? Because as we have explored and talked to a whole bunch of customers all over the world, we have realized that there have been a lot of tasks that we have been doing in chip design, which are fairly mundane. That they can be easily automated using generative AI. And Hans will talk about many of those. But beyond that, I think generative AI capabilities, if you go towards the future, can go to a point where it can become a very good consultative agent, helping senior designers. It can even start writing specifications. It can find holes in specifications and issues, things like that. It can do very large number of tasks which are quite tedious, not very creative, and can take over. So I think generative AI is going to go down the path we went down with autonomous driving. We will have something like maybe D1 where we mundane do simple tasks, then a level called D2 where we start automating, D3 when we can start doing a simple chips and doing a whole flow perhaps. D4 might be a session where it can do complete specification of a chip and design the chip for simple chips, and eventually a D5 system which can do very complex specification and full design automation, maybe 5 or 10 years from today or whatever the timeline may be. So to me, generative AI has a possibility of really bringing a lot more people around the world into chip design, which I really think is very important for democratization of silicon. And I think the other thing, it can simplify teaching, learning, and improving the cost effectiveness of the chip design. So I really am a very big believer of generative AI application into chip design. And I hope in the next 30-40 minutes, Hans will able to show you not only what are the possibilities in the future, but what we can do today. And I believe you'll be amazed with what we can do today. So with that, I would like to pass on to Hans to take us through the capabilities and potentially a demo of what PrimisAI can do today.
Okay, great. Thank you very much, Naveed, for the introduction. Thank you very much, Efabless, for hosting this webinar. So as mentioned, my name is Hans Bouwmeester. I'm happy to present today on PrimisAI and specifically our tool called RapidGPT. So I have a few slides with us which I'll share, but I think most of you are probably interested in actually seeing generative AI in action, right? That's really where, ultimately the proof is in the pudding. So I will, show a demo, really, going into several examples. It's impossible to cover the whole world, of course, of examples, but I'll go into several examples of what generative AI and what RapidGPT is and how it adds value. So let me share my slides. So as we dive in, it's really incredible how far generative AI technology has come in the past, few years, right? It's only recent. Many people didn't know about OpenAI and ChatGPT until recently. We have been at it considerably longer, deploying large language models towards hardware design. But also for us, it's really accelerated recently to the point where we released RapidGPT, which is like I call it like a pair designer or collaboration type tool. It's very different from a traditional EDA tool, which you configure and then you start it and then you get results. You need to interpret those results and maybe you have to restart the tool. But it's very different in that this is much more something which is with you. It's an assistant. It helps you. It's always, there for you when you need it. So this is RapidGPT today. And the way we see the future is really for AI agents to become an integral part of the hardware design team. They become pervasive. They make recommendations, suggestions. They do make mistakes also that will go down over time, absolutely. But it is a very human-like type of machine. And ultimately, the generative AI can even take over management-like roles. If you look at where we come from in a way when it comes to abstracting a design, then in the 70s we used to design using transistors. At some point we realized it would be good to bundle these transistors into gates to create a library with certain logic functions. And it's not like we did away with the transistors, but we built a layer of abstraction around the transistors. Now, similarly, we progressed from using RTL to design becoming more like playing with blocks, integrating IP into an SoC type of environment, to more recently, transaction level modeling and system C type of approaching. And then, of course, I think everybody can recognize what the question mark is, and that's really natural language. And it's not like natural language will replace Verilog. That's not the intention. Maybe it reduces some of the Verilog usage, but it's not the intention to replace it. Just like logic gates haven't replaced transistors, right? It's a layer around it. And we foresee that natural language can be used for many different tasks. And, in a way, we divide the world in sort of like 3 value adds, which generative AI and which our tool called RapidGPT brings to the industry. And the first one I would say is the ability for generative AI to create something. It's really, we call it creativity drives innovation. The creative aspects, like ChatGPT can generate a poem. RapidGPT can generate many things. The obvious one is, of course, RTL code, right? But don't forget, it can also generate architectural specifications, or it can generate a test bench with test cases, so it can help you with verification. It can also generate an integrated environment of IP, right? Such that you're designing with IP. So that's the creative aspect. Now, generative AI also has the interpretative aspect in that it can look at something and it can summarize it, or it can compare two things. It can really analyze. And we capture that as, knowledge equals power, because effectively it enables you to do Q&A with the AI agent, teaching you things you didn't know, or you want to know, or you want to have explained. And this can be things like, like just asking, statements, or, how do certain constructs work in your design language, whether it's VHDL or Verilog or whatever, right? But it can also be that you ask questions about the design, like what does this function do? And the agent will teach you, will basically tell you and help you explain what a certain function in the code actually is for and what it does. And then the third one also is, it can help with an IP catalog. So we actually, in RapidGPT, we marry the large language model with it's called a RAG, a retrieval augmented generation module, or knowledge base. And now we can really leverage the agent to know about intellectual property. And you can ask questions like, which algorithm does this IP implement? How do I configure it? What does this port do? What does that port do? Etc., etc. And the last one is kind of an interesting one because it sort of falls out of the first two, but we think it's important enough to separately mention it. And that is that the generative AI also is able to start executing some tasks which were very hard to automate before. And I'm thinking of, those especially tasks also which nobody likes to do. They're sort of the automated type tasks, but there are no tools for them today, simply because the capabilities were not there yet. An example is the ability to write documentation or to augment code with comments, or on the architecture side to write specifications. Now, of these, this set of examples, I'm showing all the ones in blue during the demo. I'm not showing the IP side simply because you were limited in time, and also because a lot of the attendees I know are interested in the Chip Ignite AI challenge, which is coming up, which is starting. So I thought I really show examples in that context. So we offer a number of engagement models for RapidGPT. We have a low entry level free tier. So go to our website, sign up, play with the tool, try it. But also we offer a pro with additional value add, which is a monthly subscription, which is also provided through our website. But we also offer an enterprise offering, so contact us if anybody is interested to learn more about that offer, because a lot of questions we get is related to, data security, right? Privacy of data, but also about the ability to enhance RapidGPT with our customers' IP, our customers' EDA tools, and even our customers' methodology. So this is RapidGPT in a nutshell. So it offers these capabilities, the ability to create, language like Verilog or VHDL system Verilog. We offer the ability to do verification tasks like creating a test bench with test cases, and actually to start with a test plan. We have a feature called auto review, which is really where RapidGPT looks at your code and sees if it can find any errors, any issues which need fixing. We spoke about the ability to do commenting code, so it's a very useful feature. I'm sorry, getting all excited here. It's a very useful feature for, if you receive code from somebody else and it is not really well documented or commented, you can ask the agent to look at the code, and RapidGPT will actually add the comments. I will show that. And the last feature is a feature to, if you have a set of projects, to actually automatically generate a set of documentation. So it looks at all the project files, and it'll create a comprehensive set of documentation, which can be the starting point for editing your documents. It's not meant to be immediately final, but it's really, it gets you like 80% there, that all the ports are mentioned, etc., etc. Now, a question we often get is like, okay, but why wouldn't I use ChatGPT, right? So here are some of the answers to that. So RapidGPT, we really specifically trained it for hardware design. ChatGPT can certainly do some hardware design, but it's simply not very good at it. So we spoke about the knowledge base. We offer the on-premise deployment for enterprise customers. But also we have integrated RapidGPT fully into an IDE, an integrated design environment. So there's no need to copy and paste code, right? Which you would have to do, and if you use ChatGPT, for example, or likewise tools. There's many now. We have the ability to generate documentation we spoke about, and also we have a way to accept and propose changes to the code. So I'll show that during the demo. Also, I'd like to mention for those participants of the webinar who would like to participate in the Silicon AI Challenge, more information is on the Efabless website. Please contact us because we would like to very much, as PrimisAI, enable you with a free license. For that, all is needed is an API key, and you can contact Diana at primis.ai for information on how to get this API key. And that API key will enable you to do everything I'm about to demo. So that really is, it's comprehensive in that sense. So with that, I'll actually jump into the demo. And go from here. So the first thing I'd like to talk about, and what I'm showing here, is how to install RapidGPT. So RapidGPT is an extension to VS Code, which is a Microsoft IDE. And you can see that you just install it like any extension in VS Code. It's very easy to do. And all that's needed, as we spoke about, is to install this API key. It then gives you a chatbot. So you see on the left side of the screen, you see the chatbot, and you can ask any questions similar to tools like ChatGPT. So in this example, I just asked like, tell me a joke. But any question works, of course. So next one I'll show is, a more hardware-related question, right? And this is a good example where, RapidGPT can really help junior designs, explain things about, about hardware design in general. So here's an example like, what is metastability in a flip-flop? And it explains, in detail, how that works. You can see I go pretty fast, so maybe I'll slow down the speed a little bit. So what's important is the prompt engineering. It's really how you instruct the tool to which command do you give the tool? What English language do you use? Now you'll notice that I use very short prompts in this demo. That's that's more because I'm lazy and I'd like things to flow, of course. But in reality, think about, and this is what's on our website. It shows the prompt engineering guidelines. Really think about how you instruct RapidGPT, because a change in your instruction can really make a difference. So next what I'm doing is creating we'll just do a very quick design of a counter. So I'm creating in the editor window, I'm creating the counter, and I'm showing how, very simply, you could just use a comment and press enter on the comment, and it immediately will submit the request to RapidGPT and start generating the code for this counter. So that is a very quick way to start and to play with RapidGPT. So next one I'll show is the auto comment feature. I press the auto comment command, and now automatically the tool is looking at the code and will add the features. Now what's important here is that the differences are actually proposed as changes. You don't have to accept them, but you have the option to, for every change to yes or no, accept it. And note how now we have a nice header with the inputs, the outputs, a description, and also more comments in the code. So next I'll show how you can now interact with the code using the chat interface. So I'm asking like, okay, we have a counter now, which is a 10-bit up-down counter, but I'd like it to be saturating. When it reaches the high or the low maximum, the limit, then it needs to saturate rather than wrap around. And you can see now that we're effectively interacting with the code on the right, asking the question, and it relates the answer to the question we just asked. So you can see that it now has the logic to detect, are we at the max or are we at 0? And if so, then saturate rather than wrap around. And I'm accepting these changes such that now we have a saturating counter. Now, next I'd like to show is really, what I call hierarchical composition, which is really like, okay, so how do you create a design using lower levels designs, right? Because you want to solve a bigger problem by solving smaller problems one at a time. And the example I'm giving here is for a multiply accumulate circuit. So you can see that I first asked like, okay, create a Verilog for a multiplier. You can see that I got some questions like, well, what type of multiplier would you like, signed or unsigned, combinational or pipelined? So I gave answers to those questions and get now the Verilog for a signed multiplier. Now, similarly, I'll do that for an adder. Because of course, for the multiply accumulate functionality, we need the multiplier next to an adder. And then when that's done generating, I will add the module for the adder to the editor window, such that now we have a file with two modules in it. And so next now is to really meant to show how we can create a higher level design which instantiates these lower level designs. So this is really the divide and conquer, the separation of concerns type of approach, which you would normally do as a designer. You wouldn't expect that you give one command, one input to the tool, like, generate a very complex system from scratch. No, you would really divide it into sub-problems and then tackle these first. And then, have the higher level task fixed by having these lower level problems solved. So you can see I asked it like, okay, create a multiply accumulate using the signed multiplier and the signed adder circuits. And you can see that here's our max circuit. You can see it instantiates the multiplier, it instantiates the adder, it adds the register for the accumulate storage, and that's effectively our multiply accumulate. So next we'll go a little bit more complicated in a way, in that I'll show how to design a UART and how to do a refinement, getting this UART to become more and more feature rich, if you will. So my first question is simply like, okay, propose RTL, and you can see that I get a response like, yeah, okay, but that's very open-ended. What kind of, how many data bits would you like? Would you like a parity? How many stop bits? You don't have to answer these. If you don't, you'll get an assumption from the tool. But generally, of course, it gets you to think about like, hey, what is it that I really want, right? So I'm answering here like, 8 data bits. And what did I answer for the parity? No parity and 1 stop bit is what I answered here. And you can see that it generates the code for this UART implementation. Now, let's say that we made a mistake, or maybe, the agent made a wrong assumption in that maybe it assumed that we wanted no parity, where actually we did want an even parity. Then, after we integrate it into the editor window, we can now ask it to change it. And the change I'll make here is to ask for, like, please change it to an even parity rather than a no parity. So this is really the interaction to refine the implementation as you go. So with that, now we have a still basic UART, with an even parity support. And you can see here that the state for the parity support has been added now. So we'll integrate that and accept the changes. Again, you can choose whether to accept changes, because we wouldn't want RapidGPT to just, change your entire code. It's really better to review the changes proposed, such that you agree with what the tool suggests for changing. Now, this is still a very bare bones UART. So one, can now ask questions about it. Like, if you look at UART and you see that there's something called flow control, and, we may wonder based on learning that, like, okay, does this UART implementation implement flow control? And you can see that the answer is no. And also the tool teaches you that there are actually two types of flow control you could consider, and that is, doing it in hardware or doing it in software. And so what we do here actually is we're asking, like, well, let's change the implementation to support hardware flow control. And then it knows what to do, in that it added you can see that it explains what it did. We like that also. It does not just, we configured it such that it doesn't just generate the code, right? Like, here you go, here's your code, right? No, it actually tells you what it's doing and why, right? So it's really saying, like, okay, I'm adding an RTS signal, which stands for request to send. Such that really, like, okay, here's what my code is changed for. You can also see that it adds a buffer, and you really have to look at it for some time. But it actually does implement the buffer, but not fully, and we'll come back to that later, because actually I wanted the buffer to be external rather than internal. You can also see it here, like it introduces a simple buffer management concept. So in other words, it's not really a full implementation. It's still at the conceptual level. Then, next there is also a feature for a data overrun detection, right? What if the transmitter keeps feeding data into the receiver? We are the receiver here, and we're not ready to receive it. So, we'd like to have that error detection being part of the UART as well. And this shows how that's added to it. So I'm accepting these changes. And you could actually see that the first change I accepted was one where it proposed to change the module name, which may not be desirable. So that what actually I did was I changed it back to UART receiver without the overrun. And then one more, so really to show, like, the stepwise refinement. Our UART is becoming smarter and smarter by equipping it with more and more features, right? I'm adding support for frame error detection. Also, you can note that I add the command, please make sure to include all logic in your response. That's sometimes a good idea, because sometimes it likes to say, like, well, this logic is like before, and sometimes that's not desirable. So that's an example of prompt engineering where you can help the tool, RapidGPT, to really, do what you would like it to do. Just be specific in your requests. And you get a better response. So one thing also is that you may see this little garbage bin here, is that you always have the option to undo your last request and reissue it with making some modifications. Now here I'm showing the buffer, which is not really fully implemented as a buffer. So one thing I decide to do actually is to implement that, and I will come back to that a little bit later actually, to implement that as an external buffer. But before that, what I'm doing here now is I'm asking the question, like, okay, let's just look at the code, like sort of a human being. And if you look at the code, do you have any suggestions for improvement? And you can really see it can help you like think about certain aspects you may not have thought about. I think one of the very good ones here is like the error handling. Is we added error handling, but currently the code will assert an error, but it will only deassert it if you, let me pause the video for 1 second. It will only deassert it currently if you reset the module. That may not be desirable. So a next step could be, and it's actually suggested by RapidGPT, right? By the agent. A next step could be like, well, look at your code. Maybe you want logic where you can deassert an error signal if it occurred without necessarily having to reset the full block. So that's really a very powerful way where, you know, where RapidGPT helps you to think out of the box, outside of the box. Now, next one I'm showing is the auto review. And so one thing I ended up doing is I changed the buffer. And when I did that, we spoke about this buffer, and I did actually change it, but I made a mistake when I did that. And when I click auto review, you can see that it actually found the mistake in that the buffer full was still an internal register, as well as also an input on the module. So that's the auto review feature, really helping you to look at the code. Does it compile okay? And if not, it tries to fix any compilation errors and also gives you other suggestions for the code. Now, last one I'm doing is similar to the counter. Just to finish our UART, I'm adding the comments such that we have a fully comprehensive commented UART. I just accepted all the comments. You know, maybe you would not want to have all of them, but you can, of course, choose that. But what's very important and very nice is that you get this header with the inputs and the outputs and as well as a description. Now, one thing we've been doing is that we've sort of worked with the specifications in a, you know, a little bit an open-ended way, right? We started with this very high-end questions like, you know, I need Verilog for UART. Then we started adding stuff. We started changing stuff. It's easy to lose track of like, what is now really the spec for the UART? I apologize, actually. I'm running ahead of myself. But let me finish my thought here. Is you can ask a question where the agent, where RapidGPT will actually summarize all the specs for you, such that you know exactly, and I'll come back to it later. It's actually the next thing in the video, where you know you really know exactly like, okay, this is what I implemented, or this is what the code is doing. So we'll come back to that later, and I will go back a little bit, because the question I ask now is, okay, we have now the code, but we'd like to generate a test plan for it, right? Because we need to verify the code. So I'm just asking, please propose a test plan. And I think this is one of the very powerful aspects of RapidGPT, again, in that generative AI really is exceptionally good at thinking outside of the box. So you can see that it really gives a comprehensive test plan. And I would say if I would have a junior engineer joining the organization and I would ask them for a test plan, and I would get a you know, thinking outside of the box, like, you know, think about the basic functionality, the baud rate. It tells you exactly like, you know, what test you need to implement, the parity bit handling, the frame error detection, the overrun detection, the flow control, the reset, stress testing for edge cases. You know, if a junior engineer would come with a test plan like that, I would say like, well, hey, you know, good job, right? You're hired. So what I'm doing next is I'm for one of the test cases, in this case, test case number 5. I forgot which one that is, but we'll come back to that later. It's a good idea to take each test case individually and create an individual test bench for each of them. And I believe this one is actually for the, this is for the overrun error detection, which is case 5. And you can see that we get the test bench, which instantiates the module. It initializes the signals. It applies the reset. It generates the clock, and then it applies the stimuli to the unit under test, and really gives us a pretty comprehensive, definitely a very good starting point for a test bench.
Hans, I don't mean to interrupt, but I just want to make you aware that we have about 30 questions.
Okay, yeah, well, I'm almost there. I'm getting there.
Okay, perfect. Thank you.
I can also change the playback speed a little bit. I'll go to 1.5 times. What I'm showing here is to just ask a question about the test bench. Again, this is very useful, like if you forgot, or if a language which is used is new to you. So I'm asking here, like, what does the timescale directive do? I'm also asking a question like, what is this task here, to show, like, you can ask it to explain features in the code. And it'll exactly say, like, okay, this is what this task is doing. And then last, I can even go to 2 times. And because essentially we already spoke about that, because what I'll do next is actually ask for a set of specifications. Oh, I think there's one more test bench I'm generating here for another test case. So I can actually jump ahead a little bit. And just to make sure we have ample time for questions. So this is another test bench which is generated in a similar way. And also I'm saving that one. This is the other test bench, because what I wanted to show is what we spoke about is also, yes, is coming now, is really like what we spoke about, like I'd like to see a set of specifications. And this shows that, when it comes to generating something, never forget, you can also just generate English. It doesn't have to be RTL code. And you can see here that we get a comprehensive set of specification in English language. So, it tells you, like, again, what the outputs are, the parameters, the functionality, a description. So it's very quick way to learn about, what is it doing and why. So next, what I'll show, I'll go to 2 times playback speed again, is the ability to do automatic generation of documentation. So it's the AutoDoc feature. And I'm just asking, like, how does it work? You don't have to go to the manual. Our manuals are integrated into RapidGPT. So it effectively explains something out of our user manual. And then next what I'll do is I'll generate documentation for the project, which is the UART with the test benches. And it generates a docs directory, which I'm going to now, which has a install instructions and a make file. And when I follow those instructions, I install the required Python code, and I do a make HTML. It gives us the website, and then browsing to the website, index.html, you can see that we now have the starting point documentation completely, human readable and presented as a website. You can see the UART receiver module and test benches. Here's the description for the receiver, and here's a description for one of the test benches and another test bench. So everything we just created is summarized. So next what I'm showing, and this is the last before we go to the question, is I thought there will be an interest potentially in that, many of the participants would like to participate, or in the Chip Ignite AI challenge. And you may be familiar that Efabless has a little video showing an example of you using generative AI for a certain specification. And what I'm showing here actually is that that specification, which is, let me go back 1 second here.
Almost a year old to the day, Hans.
Oh, oh, Andy, yes, because I saw you did that video. So Andy, here's actually the instructions you gave, right?
Yep.
So it's about, Verilog for a counter which is connected to an, or is actually an APB client, right? So it's connected to an ASIC peripheral bus. So I'm just asking the question, I did this. This also shows, by the way, how I just opened the file. And that file is associated with the chat. So, I just opened the file, and because I did this earlier, it just remembered, it knows the questions I asked at the time. Now you can see here the answer of RapidGPT. Again, it's more than just code. It also gives an explanation. And also I noticed that there's a buffer. It asked the question like, would you like to have this buffer internal or external? So that's a very good consideration, right? I'm asking you to rewrite it a little bit, and ultimately I end up with, with the code on the right, which would still need to be verified, of course. I'm also asking a question here like, hey, what is APB? Just to help us understand like how the AXI peripheral bus works and what it does. So I'm accepting the changes which were proposed. And I think, last is I added the comments, and here's our counter with APB.
Thank you, everyone.
Okay, great. Thank you so much, Mohammed.
Thank you. Thank you very much. Take care.